Previously gathered evidence indicated that on the night of the accident, the three-man crew was in the process of connecting the control blades to the drive mechanism when the excursion occurred. Now, this is the routine procedure they were believed to be following. First, the shield plug is slipped down over the rack. The pinion gear housing and spring housing follow. The pinion gear is inserted in place. The lifting tool is then inserted into the spring housing and threaded onto the rack. The rack is then lifted a few inches out of the housing to place the C-clamp on the rack. The handling tool is lowered until the C-clamp rests on the spring housing, thus holding the assembly in place. The handling tool is removed, and the retaining washer and nut are placed on the rack. The handling tool is screwed back on the rack. The handling tool and attachments are lifted to remove the C-clamp. It was near this point in assembly that the excursion occurred. Physical evidence shows that the nut, washer, and handling tool were on the central control rod at the time of the accident. The evidence was consistent with the possibility of hand withdrawal of the 85-pound central control rod blade to the 20-inch position. To test empirically that this is possible, a control rod drive mechanism was assembled over a pool of water, and attempts were made to withdraw the rod with reasonable efforts and maximum efforts. Similar tests simulating stuck mechanism conditions were also conducted. All data were recorded on an oscilloscope. It was concluded from analyzing the data that an average man could withdraw the blade fast enough and far enough to reach the observed 20-inch final position before steam generation terminated the power excursion. The experiment further showed that a 20-inch withdrawal would not likely result from trying to free a frozen rod assembly. The animated scenes that follow depict the complex sequence of events that are believed to have occurred during the accident. It is important to remember that the whole sequence probably took place in less than 4 seconds. The direct cause of the accident clearly appears to have been manual withdrawal of the central control rod blade by one or more of the crew members considerably beyond the limits specified in maintenance procedure. However, there was insufficient evidence to establish the actual reason for such abnormal withdrawal. Now, in slower motion. Regardless of the withdrawal mechanism, the central control blade was lifted approximately 20 inches. This was 3 to 4 inches above its critical position of 16 to 17 inches. Approximately a 2% supercritical condition resulted, corresponding to a period of about 4 milliseconds. This supercritical configuration caused the rapid production of neutrons by fission for a total energy release of approximately 130 megawatt seconds. A metal-water reaction probably contributed 20 MWS additional energy release. The fissions occurring within the fuel plates increased the temperature of these plates to a point near or above melting, depending upon location in the core. In the center regions of maximum neutron flux, the fuel within the plates experienced vaporization temperatures and burst the plate cladding. Thus, the spewing of hot vaporized fuel rapidly produced steam in the surrounding water. The steam was generated at a rate far faster than could be dissipated, and the resulting outward expansion of this high-pressure steam bubble of at least 500 psi damaged the core. The central blade was seized by the shrouds surrounding it, and the two became an integral unit. At this time of seizure, the central blade was withdrawn about 20 inches. The steam being generated pushed upon the water that was above the level of the core, forcing a slug of water upward from the core zone. It was stopped by the vessel head, with a resultant water hammer causing peak pressures of about 10,000 psi. While the water was moving upward, the core structure jumped, reaching a height of 7 inches above its supports when the water hammer hit the head. As the water was decelerated upon striking the vessel head, the forces generated collapsed the shield plug guide tubes. It also deformed the vessel wall and the vessel head nozzles. Additionally, the momentum of this water, as it struck the vessel head, transferred its energy to the reactor vessel, imparting a vertical motion to the shield plugs and to the vessel itself. Some biological shielding material was ejected from its container on the vessel head. The vessel jumped approximately 9 feet, sharing the connecting pipes and expelling some of the surrounding thermal insulation. Simultaneously with the vessel lift, the pressure within the vessel expelled the unbolted shield plugs. The ejected shield plugs came to rest in various locations. Number 4 in the fan duct, number 3 on the fan floor, number 1 and number 7 in the operating room ceiling. The central plug hit the ceiling and fell back on the vessel head as the vessel dropped back to its original position. Reconstruction of the movement of the central mechanism gives greater insight into the physical damage observed on the rod. Initially, the rod was withdrawn approximately 20 inches. As a result of the core jumping during excursion, the central rod was moved upward an additional 7 inches. The water hammer pressure then bound the rod and tube together at this relative position of 27 inches. The plug and rod were accelerated as a unit from the nozzle by the high pressure. Upon hitting the ceiling, the handling tool snapped the threaded end of the rack, impaling the tool into the ceiling. The impact also broke the rack inside the plug and simultaneously caused the plug to slip back up the rod to the fully inserted position. The plug flange then hit the overhead structure and the fractured rack continued into the fan room. The plug fell back onto the vessel head, snapping the connecting rod after it had been driven upward through the plug about 3 inches. The scratch mark evidence and matching marks on the tube and extension explain the seeming discrepancy of finding the central shield plug with the final rod withdrawal position only 3 inches above the normal 0 position.